Okay guys, so in this lecture we'll be continuing on seeing the total number of Grignard region that can attack as a base or a nucleophile on a given organic compound. So this would be our last lecture on practicing on the Grignard region. Okay, so let's take this example. We have something like this. This CH2 here, and we have another phenyl ring here. OET here. Okay, so how many total amount of Grignard reagent can be there attacking on this is, for this we can have this as a leaving group, this as a leaving group, 2 CS3 attached, and one more CS3 scope is there, hence 3. Again in this case we have only one scope because no leaving group is there. We have to attach one CS3, and after the attack of only one Grignard reagent, it will form a secondary alcohol at this position. Okay, so one can attack here. What about this position? Two Grignard reagent can attack here because one can be a leaving group, and another CS3 can be attached here, forming a alcohol at this position. Okay, so you can count total amount of Grignard reagent required, so it would be 6. Let's look at another example. We have something like this. So how many Grignard reagents in this case? This a leaving group, this as a leaving group, 2 OH will be formed here, this bonds would be cleaved, 2 CS3 will be attached here, and would still have a scope of one more CS3, so as to convert this carbon atom attached with a 2-degree alcohol, so 3 in this case. Okay, let's look at third example. We have something like this. So how many in this case? So for this it can act as a nucleophile, so one here and here there is a one leaving group, and one more CS3 can be attached here, so 2, total 3. Okay, what about this case? Again we can have 3. Why? This a leaving group, this is a leaving group, 2 CS3 get attached, one more can be attached by forming this as a alcohol or 2-degree alcohol. So answer for this case would be 3. Let us look at this example. We have something like this. How many can be attached? Only one, because there is no scope for any leaving group. One CS3 can be attached here, thereby forming this as a 2-degree alcohol again. Okay, so what about this? So acetyl, and we have hemiacetyl. I hope you remember their compound structure. So we have acetyl as something like this. On this, no Grignard reagent can attack either as a nucleophile or as a base. It does not have any scope. Okay, because there is no double bond here or C double bond O, so that it can attack as a base, or rather it can attack as a nucleophile. Okay, and it does not have any acidic alpha hydrogen also. Okay, and for hemiacetal case we have something like OH and OET on the same carbon atom. Hence what can happen is CS3 minus or CS3 MgBr can actually can attack on this hydrogen, because it is as a base, because it is a acidic hydrogen, and as a result it will have something like O minus and OET. What next step the oxygen attached to the carbon atom would do is, it will have a double bond with the release of ETO minus, and now on this double bond again one Grignard reagent can attack to form something like this, and CS3 as well. Okay, so total number of one here and one here. So 2 in this case can actually work on this semi-acetal to form product something like this, and 0 in this case there is no scope. Okay, for either Grignard reagent to act as a base or a nucleophile. So with this we come to an end on practicing all the sessions and examples on Grignard reagent. From the next lecture onwards we'll be having a new concepts called aromatic chemistry. So we'll be having a lot of fun discussing all the concepts and all the reactions in that chapter as well. So till then, good luck and goodbye.